And welcome everybody to the daily space weather. We're looking at the sun here, the northwestern quadrant of it. Sunspot 2824 on your left, sunspot 2826 on the right, which has grown spectacularly over the past 24 hours. We'll also be talking about electronic and ionospheric anomalies and additional coronal mass ejections and lots more. On today's video, let's take a look at the magnetic fields associated with these two sunspot groups. They both hold the type of field complexity required to produce significant solar flares. Don't be surprised to see some, and don't be surprised to see additional coronal mass ejections sort of in the Earth-facing zone. We saw one on the far side of the sun recently, and we've got so many things to cover we're not even going to talk about it. Some massive plasma filaments up here in the northwest as well. You can see up here perhaps bunch of plasma, and there's also a bunch of plasma down here, some of which is extending well out into the corona. Again, likelihood of an Earth vicinity coronal mass ejection very high, near 100% at this point. Here's a diagram of the solar system. Did you enjoy yesterday's full lunar eclipse, the total lunar eclipse yesterday? Did you check it out? Did you check out smashomash.com/forum? We've got a thread about it. Anyway, there's where things will be in the solar system in 1 week. Here's a star chart. I like to use in-the-sky.org. And here over Lehigh Valley, we've got the moon and Saturn and Jupiter up there. If you've got clear skies, you can see those near the ecliptic before dawn. Saturn and Jupiter. The 10.7 centimeter radial flux has jumped up to 88, so a precipitous uptick there in the radial flux as we forecasted. Here's the 1 year chart of that. It's this black line, and you can find that chart if you like at solon.info. We just saw brief geomagnetic storm conditions, and we've come back down to a more calm condition here. Basically, the NOAA forecast was pretty much right on for the early hours of May 27th. This is the Space Weather Enthusiast dashboard, and you can see no significant space weather expected in the next couple of days. Let's check out seismicity. Really, what's going on? There's been a lull in earthquakes. And here are the 4+ magnitudes, hardly any. And it looks like only 2 5+ magnitude quakes over the past 24 hours. Let's roll up the list here on the USGS site. I'm just going to let the list scroll here. It's pretty uneventful over the past 24 hours, folks. A couple deep quakes in South America, a deep quake at Russia, and in the Caribbean at the Dominican Republic. Volcanoes also calming down. Kilauea has stopped erupting. Nevada State Chilean unable to detect whether or not the central Chilean volcano is erupting. Let's talk about volcanoes and earthquakes, mainly earthquakes. What causes deep earthquakes? Well, inclusions in diamonds perhaps give us some insight into that. So while those inclusions in that diamond right there would reduce the value of it if you want it for your jewelry, they increase the scientific value of it because they give us insight into how those diamonds formed. So we know there must be fluids at very deep depths, and we're talking about 300 kilometers and below. And inclusions in diamonds give us a chemical analysis of how those diamonds formed, an indication that there are indeed fluids at these extremely deep areas. Probably an indication that the Earth contains liquid metallic elements, whether that's liquid metallic superionized water or liquid metallic hydrogen or other elements, remains unknown, as we barely even scratched the surface of what is inside planet Earth. Perhaps check out this phys.org article about how diamonds are giving us insight into deep earthquakes. By the way, I would remind all of our viewers to not pole vault the caldera. Here at smAshomash.com, we prefer our users to be safe. So don't pole vault the caldera. Let's get back to some space weather information. The GOES X-ray flux over the past 3 days showed a couple of C-class flares. At least 3 significant C-class flares, actually really like 6 of them. All in the lower part of the C-class range there. So some solar flaring coming out. No spikes in the proton flux. So solar flares, no major coronal mass ejection strikes as we would see a proton event here, and we don't see anything of the sort. GOES magnetometer looking spiky here as a different current sheet arrives. Let's take a look at that. Here's the Gong 2 data showing the heliospheric current sheet's polarity. And you can see this indecision happening in between stereo A and Earth. So this is the location of stereo A right here. That's Lagrange point 5. Here's stereo B. And this area right in here, a little bit indecisive as to the polarity of the current sheet there. It may be an indication that we're about to see some South Pole, some Southern Hemisphere activity, like maybe we'll see a sunspot in the Southern Hemisphere, and we'll look at colorized magnetograms later in the video. Here's a line of sight ecliptic plane field plot. We just showed you the top view. Here's the line of sight, and you can see these indecisive moments over here where the North and South Pole are battling over the polarity of the current sheet at the altitude, at the latitude of the Earth. Next, the line of sight coronal hole plot. And I would say that there is a lot of pressure building in the sun right now, as we have not seen very many coronal holes. So we're seeing actually a very low amount of coronal holes. We're seeing coronal holes extend down toward the equator and then retract back toward the pole again. So I think there is a lot of intercalate pressure building, and the intercalate regions would be the areas in between the layers of hexagonal planar lattice on the sun. Coronal holes represent that pressure being released. Coronal holes are low pressure systems, and we're really seeing a shortage of coronal holes during this solar cycle. So here is another pair of animations here: detected filaments and detected sunspot groups. Again, sunspot 2824 and 2826 both harbor the type of magnetic fields associated with significant solar flares and coronal mass ejections. There's a bunch of plasma up there. It could be released if those, especially if those see large solar flares. So that's something to keep an eye on throughout the day. And we do see some filaments down here showing up, as we said earlier in the video. The ones up here in the northwest are showing up less on the detected filaments. However, I assure you that they are indeed there. And you can see this brief period of geomagnetic storm, currently in a period of geomagnetic unrest. And we'll show you some of the magnetic situations associated with that. First, the real-time solar wind. Give it a moment to load, and there you go. So we saw the solar wind density make it all the way up to about 44 protons per cubic centimeter here yesterday. That was the coronal mass ejection strike, so we got a great signal here. Our patrons found out about it quite instantly, and we saw a change in the BTBZ, a small change signal in the phi angle, but mainly the density, the pressure, and the temperature. So these bottom 3 panes here showed us a major signal for yesterday's coronal mass ejection strike. And those coronal mass ejections were moving a little bit more slowly than anybody expected. But there's the data on that. And really, the coronal mass ejections are still striking now. That's why we're in a period of geomagnetic unrest. So here's the magnetohydrodynamic pressure here in nanopascals. This is a model from the Space Weather Modeling Framework, and if you want to read about that, scroll down to the bottom of the Geospace Magnetosphere Movies page and click on Details. You'll find links to where the data comes from. And we're seeing a high pressure environment here as a result of this higher density solar wind associated again with some coronal mass ejections. A little bit of a reduction in the pressure there at the end. Here are changes to the Earth's B field, geospace delta B. Ground magnetic perturbations. So like the last little video we showed you there, this is also 4 hours. And we show these each day, whenever they're available at least, and most days they are, on the daily space weather. We're going to let this play through as it refreshed. And you can see the evidence of 2 geomagnetic north poles there over on the left. And here is the global view. I would also note major geomagnetic perturbations here south of South America, this area right here, making it look almost like the south geomagnetic pole has split. Since the south geomagnetic pole is way over there, someplace south of Australia, well away from the Antarctic continent and the geographic South Pole. Some serious perturbations over Canada and Siberian North Poles as well. By the way, if you want to follow induction into the U.S. power grid, check out the Geoelectric Field 1-minute empirical 3D model. And during times of geomagnetic storm, we see the power grid we see the incoming solar radiation causing increased voltage in the power grid. So this is a way to monitor it, and you could use this to forecast the likelihood of things like power outages. And you're looking at millivolts per kilometer here, folks. And you can see some significant induction caused during this most brief period of geomagnetic unrest. Next, it's time to stream live for the cosmology segment. And we're streaming live to Twitch for this. Next, I would like to thank our YouTube viewers. Thanks so much for subscribing, viewing the videos, leaving comments, etc. We greatly appreciate you checking out the channel. And we've barely even gotten started. We are far from full time at this point, folks. So don't forget to press like and subscribe if you enjoy the content. And don't forget to tell your friends, your foes, your science noobs, and your science pros about the channel. Lots of content besides daily space weather, cosmology, and meteorology segments on the playlists, so check those out. Again, thanks to our subscribers on YouTube. Thanks to our BitChute subscribers as well. There's exclusive content there. And we like to stream live to Twitch. By the way, we'll be streaming live at the moment of the solstice. So on June 20th at 11:32 and 9 seconds p.m. Eastern Daylight Time, we will be streaming. So make sure you join us for that. We'll be on multiple platforms, at least YouTube and Twitch, possibly also Facebook. Before we do the cosmology segment, I'd invite everybody to view our own website and welcome you to the Neo-Renaissance. smAshomash.com, smashamash.org will redirect you. You can find our social media there. Let us know in the comments what your favorite social media is. We are on many, many of them. And again, you can find links there. Check out our merch as well. It's of very high quality, like our patrons, the main source of funding for the content. And please consider becoming a patron if you'd like the earliest alerts and so on. Also multimedia and all kinds of other science articles nobody gets access to. I mean, they get access to, but do they really understand how it ties together with the other information? Maybe they do, maybe they don't. Patreon.com/smashomash for some insight you may not otherwise get. So today's cosmology segment is absolutely fascinating, just like yesterday's. If you didn't watch yesterday's, check out yesterday's cosmology segment. YouTube.com/smashomash/playlists. What about the possibility of helium rain inside Jupiter and Saturn? So there is a new frontier going on right now in science, folks. The frontier of material science is superionized high-pressure materials. It's pretty interesting that common elements, when experiencing millions of atmospheres of pressure, turn into superionized metals and form into a superionic liquid state. They turn flat black. They behave like superconductors. So perhaps have this read about how there are metallic fluid rains caused by the high-pressure environment at places like Jupiter and Saturn. This article on the phys.org's Astronomy and Space section. And also perhaps check out this article here. It's a PDF you can find, The Physics of Superfluid Helium. Kind of interesting, to say the least. So maybe have a read on that as well. It also includes your helium phase diagram. Today's random number is 565, which coincides with this object. It's a high-mass X-ray binary. And I didn't memorize the name. To quote Einstein, never memorize anything you can look up. Anyway, here it is in X-ray. That's from the XMM Newton, and we're not going to see this in very many different wavelengths as it's in a very busy part of space next to a giant cloud of hydrogen. Here's the infrared spectrum, and you can see how busy that area indeed is. And let's see if it shows up in red light. And perhaps that's both stars of the binary there. I have a feeling one is dark and one is light. So that's today's, quote, random, end quote, object. It's Swift J1633.8-4724b. Here are the X-ray transient outputs from that. It's a pretty inconsistent X-ray source. We've only got a very limited amount of data on this one. Looks like not even a year of data on this X-ray source. If you want to look up your favorite transients, head to the Neil Gorell Swift Observatory. For example, if you want to look at Sagittarius A stars outputs, type in SGR space A. It'll link you to number 705. And there are the X-ray emissions from the core of the Milky Way galaxy, Sagittarius A star. And by the way, if you're wondering what Sagittarius A star looks like, the area around Sagittarius A star, that's what it looks like. It's being orbited by a series of supermassive stars, blue supergiant stars that are so big that if they were in our solar system, they would be about the size of Mars's orbit. In other words, you'd be inside them if they were in our solar system. These stars orbiting the galactic core, Sagittarius A star, at relativistic speeds, hundreds of kilometers per second, only a few years periodicity in some of their orbits. So the cores of galaxies are very complex places. The Milky Way galaxy is a very complex place, and that is the sort of thing going on in the core of the Milky Way galaxy. Next, talking about magnetism in the sun and coronal mass ejections and magnetic bubbles and reconnection and so on. Now, we regularly look at GONG hydrogen alpha imagery. It's part of our bonus features on the daily. Reconstructing topology, magnetic topology that is, of on-disk solar prominence bubbles. Another article in the phys.org's Astronomy and Space section. Some three-dimensional magnetic modeling here of magnetic reconnection events associated with the ejection of plasma filaments. So this one may be interesting to you, especially if you're unable to forecast coronal mass ejections. So check out that article there in the phys.org Astronomy and Space section. And we've got a radio telescope here, AVRO. Yes, AVRO, showing up in the NASA astronomy picture of the day. So here is a total lunar eclipse, along with phases of the moon, along with an image of the Owens Valley Radio Observatory, AVRO. So that's today's astronomy picture of the day. You can look at it yourself and others at apod.nasa.gov. And yesterday we talked a little bit about the wobble of the Milky Way galaxy as all orbiting objects, all rotating objects precess, meaning if you spin a top, it wobbles. And that's kind of important because, well, it's associated with a couple different things. So, regarding the behavior of black holes, they have a hard state and a soft state. In their hard state, shown here, their jets emit X-rays. In their soft state, their disks emit more various aspects of the electromagnetic spectrum, and there is a relationship in that when they go into a hard state, they emit less radiation from their disks, and when they go into a soft state, they emit less radiation from their poles. It's because there's an inverse proportional relationship between the output of the poloidal fields, which are these fields, and the toroidal fields, which are the fields in which you live, the donut-shaped magnetic fields, which are a net result of the overlap of these poloidal fields, the fields from the poles. So here's yet another article about this. Another article from the phys.org Astronomy and Space section. It was quite rich in interesting material today. Similar states of activity identified in supermassive and stellar mass black holes. Now this is a situation here, folks, where black holes and stars seem to have a lot of similar properties here. Does this tell us some insight into how the sun's behavior is? Well, it certainly does. So perhaps check out this article as well, another phys.org article in the Astronomy and Space section about the way supermassive black holes appear to behave the same way as stellar mass black holes. Supermassive black holes are as massive as billions of times the mass of the sun. At those massive radio sources, stellar mass black holes are as little as 2 solar masses estimated mass. Another article here about the soft state versus the hard state and the proportional relationship between the poloidal and toroidal fields of stars. That's today's cosmology segment. We hope it was as fascinating as yesterday's. And we'll have to say goodbye to Twitch as we continue on with the daily space weather. Here at the Smash News Network, the next thing we're going to cover is Van Allen belts. Here's a diagram of them. And during geomagnetic storms, did you know we'll get a third Van Allen belt sometimes? Yes. These shrink. We get a third one. It's just what happens during a geomagnetic storm. We can also see charging hazards caused by the electrons out there. And indeed, we do see some charging hazards over places like Northern South America, Central America, Florida, the Caribbean, Mexico, and about to move into the Central Pacific region. So some charging hazards happening as a result of, really, it's inhomogeneous electrons, as we're seeing erratic electron belts. Here's a 1-year chart of the electron flux, and here's a 3-day chart. So despite seeing low levels, we're seeing high-density blobs of electrons up there. Here's the electron content forecast. And while we've seen a dip in the total amount, we're seeing some oddities. Again, I would bring your attention down here. You're going to see some very high density regions forming there around Antarctica, south of Africa and South America. So there are 2 very weak spots in Earth's magnetosphere. One about here, that's the South Atlantic anomaly, and one down here, the South African anomaly. And south of those areas, we see some serious ion fountaining happening, some very dense regions of electron flux near Antarctica. So I'll just pause the image here on the, there you can see those very high dense regions happening there. Some major anomalies there in the electron flux. And there's probably nobody there to see massive GPS errors in those areas. They wouldn't be expecting them. That's the total electron content. Next, we're going to show the ionosphere, which is also looking a little bit anomalous here. I would bring your attention to this F over here. That's the 300-kilometer line there where the F ionosphere is located. And this is looking pretty anomalously here as well, folks. We're seeing some rapid vibrational increases and vibrational decreases. Each one of these colored blobs represents 1 megahertz of difference. And you can see it's quite wobbly in the ionosphere right now. We're seeing it charge down, charge up, as well as some anomalous locations of the high-frequency regions. And I would remind you that megahertz are millions of vibrations per second. The ionosphere is in many ways the bridge between space and Earth's atmosphere. Let's bring up the latest image. That is from 9:30 Universal Time. Next, we're going to do a meteorology segment. And let's stream live to Twitch for that. Should be an interesting one, as there are some more interesting stories again. An exciting day for things like space weather. So first thing we're looking at here is the jet stream scenario of the Western world. And look at how chaotic the jet streams are in the Northern Hemisphere. Totally all over the place, incoherent, blowing north and south, blowing backwards in some areas, such as over the North Atlantic there. A little more coherent in the Southern Hemisphere, but also doubled up and tripled up over places like the Southern Pacific Ocean. Let's take a look at surface winds of the Western world. There are surface winds from nullschool.net. We've also got some heavy wind forecasts for places like Texas. We'll get to it in a minute. First, surface winds of the eastern world. We're continuing to see some strong low pressure systems here, south in between Australia and Antarctica down there. A powerful clockwise rotation in the southern hemisphere indicates a low pressure system. Clockwise rotations in the northern hemisphere indicate an anticyclone and a high-pressure system. Here are the jet streams of the eastern world and some extreme kinks in the southern hemisphere and a powerful low here in the central Pacific as well. Winds from severe storms could rival Cat 2 hurricane. So expecting winds of like 100 miles per hour in those locations shown in red. Also some hail reports coming in for the past 24 hours. Some 3-inch hail showing up in Texas. Leave us a comment. Let us know if you've seen any severe weather. Feel free to post about it at smAshomash.com/forum. It's still free. smAshomash.com/forum. Set up an account. And we may share your content on ours. Next, we'll take a look at lightning. We saw a severe thunderstorm here in eastern Pennsylvania. We're located in Lehigh Valley, and I was actually using lightningmaps.org. Check out our Instagram account. You can see some severe lightning scenarios shown on there. Hey, Kansas City, there's thunder rolling in. Also, Des Moines. Some significant thunderclaps to your west. Anyway, there's lightningmaps.org, the full Earth map. And here's the NASA Goes Lightning Mapper. And I just want to check the life of the stream real quick. And everything looks A-OK. Here at the Smash News Network, least busted name in news, we like to also show where pressure cells are. And you can see this significant low pressure system here. It's more of a pressure gradient than a powerful low, but because of the higher pressure region around it, it is a significant pressure gradient there that is currently centered over Iowa. And we're going to advance this into the European forecast for tomorrow. There's the European forecast for pressure at 12 noon Eastern Daylight Time tomorrow. Again, Smash staff and I are located in Lehigh Valley, Pennsylvania, right about there. And here's a U.S. Doppler radar map. A lot of moisture there in the central U.S. right now, west of the Mississippi. Here's what's going on in the cloud layer. And here's your water vapor map. And it looks like the jet stream is going to be influencing this moisture here a bit, providing somewhat of an impulse, although you may see this turn a bit to the northeast as a result of colliding with this dry mass of air. So this is a high pressure right here, at least comparatively speaking. It may cause a bit of deflection. You may see this moisture move a little bit more to the northeast as opposed to due east. And it looks like it's already actually making a bit of a turn there. You can see it on the Doppler as well as the cloud layer. And that's today's meteorology segment. Thanks for tuning in. We'll have to say goodbye to Twitch as we continue on with our bonus features in the daily space weather. First bonus feature is the latest hydrogen alpha imagery. This one's from El Teide, Spain. It's only about less than 4 minutes old. And you can see some of the filaments up here. There's a filament there you can easily see. And this filament down here is the most likely one to eject. Don't be surprised to see that eject today. I would say there's a near 100% chance of a coronal mass ejection in the Earth-facing vicinity. Check out the Integrated Space Weather Analysis Center if you want to see a non-Earth-facing coronal mass ejection. There was one on the far side just a few hours ago. We're not even going to cover it because there is too much to talk about. Some big sunspots. Sunspot 2826 is quite significant. Now the largest sunspot on the disk and more than capable of producing significant solar flares and coronal mass ejections. So once again, there are sunspot 2824 and 2826. There's the colorized magnetogram. Fantastic views of those. Here's a full disk image at 171 angstroms, my favorite wavelength, from the SDO, the Solar Dynamics Observatory. We've also got some additional sunspot regions possibly forming here. Again, not even going to talk about it as there's too much important stuff to talk about. And we'll close out the video with a couple more close-ups. Here's 1700 angstroms, giving you a great view of some flaring there. You can see some little brightening in those regions, as well as the growth of sunspot 2826. 2824 has remained quite stable here over the past 24 hours. And last but not least, here is a composite featuring 94 and 131 angstroms, both ionized emission spectral states of iron. It's UV light. And we are out. Thanks for tuning into the Daily Space Weather. Don't forget to press like and subscribe if you enjoy the content. Press share on your social media. I've been your host, Dan, a.k.a. smAsho. Wishing that solar wind be at your back.